Hello, so today we will solve two more exercises on combination of capacitors. Okay, so considering the adjacent circuit, calculate the equivalent capacitor of the capacitors in the figure. So we have to look for combinations of series and parallel. So directly one can see that these two are in parallel. And then this one and this one and this one are in series. Okay, so let's give them some names as this makes our life easier. So let's call this one C1, C2, C3, and C4. Okay. So I have C1, C2, and C3 implies C2 plus 6 microfarad, 8 microfarad, then C1 and C2 and 1 over C equivalent, or 1 over C1 to 4, which is 1 over C equivalent, is equal to 1 over C1 plus 1 over C3, 4, and from this I will get C equivalent is equal 2.67 to the minus 6 farad. 4 to the right, or 2.67. Find the charge on each capacitor. So this is part A, now part B. Find the charge on each capacitor. So if we look here, we will find that Q1 is equal to Q3. Why? Because each, remember when they are in series, when they are in series, the Q's are equal, and these are equal. So Q1 equal to total in the circuit, which is C equivalent times E, which is 2.67 e to the minus 6 times the total voltage, which is 9, and this will give me 2.4 e to the minus 5. Okay, then I have to get Q23, so C2 parallel implies Q2 over Q3 over. Okay, you have to remember this formula when we have a parallel. So we have this equation. So Q2 is equal to Q23 times C2 divided by C23. This is equal. What is Q23? It is this value, so it is 2.4 e to the minus 5 times C2, which is 6 e to the minus 6 divided by C23. C23 is here, it is 8 micro, so 8 e to the minus 6. Let me tell you, C2 is equal 1.8 e to the minus 5. Same formula, we get Q3, so Q3 divided by Q23 is equal to C3 divided divided by C3 implies Q3 equal Q3 divided by C3, and this is equal to 2.4 e to the minus 5 times C3 2 e to the minus 6 divided by 6. This gives us 6 e to the minus 6. Finally, part C, the potential difference across each capacitor. So this one we get it from the formula Q equals V. So if I want V1, it will be Q1 over C1. If I want V2, it's Q2 over C2. V3 is Q3 over Q3. So and V4 is Q4 over 4. So what is Q1? Q1, it is here. Q1 equal to Q2 equal to Q4 equal to 2.4 e to the minus 5 divided by C1 is 8 to the minus 6. And the Q2 is 1.8 here, 1.8 e to the minus 5 divided by which is 6, and V3 is V3, which is 6 e to the minus 6 divided by C3, which is 2 e to the minus 6, and finally this is Q4, which is 2.4 e to the minus 5 divided by C4, which is 8 e to the minus 6. Okay, and to just use the calculator to get these values. Okay, so let's do another exercise. This is exercise 7, page 57. So I have the capacitors on the right. Again, we have to get the equivalent capacity. And then the charge of each capacitor and then the potential difference across each capacitor. So what we observe immediately, we observe that these two are in series, these two are in series. So if we call different names, so if we give this one C1, so what do I have? I have C1 and C2 are in series, C3 and C4 are in series. This gives me C12, this gives me C34, and then C12 and C34 are in parallel. So let's start. One over C12 1 over C1 plus 1 over C2. From here we get C12 is equal to 2 e to the minus 5. Let us use our calculators. And then C3 and 1 over C4, 1 over C3, 4 and 5, 4 numbers we get to 1.33 okay, or microfarad, and then C12 and C24 parallel implies we're going to the sum of C12 plus C24, and this will be 3.34. So this will be C12 plus then we have to get the charge on each capacitor. Okay. So we need to get the charge on each capacitor. So what do we see? We see that Q12 is equal to Q1 is equal to Q2, right? So we have to get Q12 and then we have Q1 and Q2. And why? Because C1 and C2 are in series. Then I have C3 and C4 are in series. So Q34 is equal to Q3 is equal to Q4. Again, so this is and this is equals C4. Then how to get Q12? Q12 and Q34 are in parallel. Plus Q12 over Q total equals C12 over C total, which we call a C equivalent. Okay, so for this we have to get Q total. What is the Q total across the whole circuit? It is C equivalent times V total, which is 90. So this is C equivalent, which is 2.33 e to the minus 6 times the total voltage, which is 90. And this gives you 3 e to the minus 4 coulomb. Okay. Now I come back to my Q12. So Q12 is equal C12 times Q total divided by C equivalent. So Q12 is equal. C12 is, here it is, 2 e to the minus 6 times Q total. I have just calculated it, 3 e to the minus 4 divided by the equivalent, which is a 3.33 e to the minus 6, and I will get Q12 equal 1.8 e to the minus 4 coulomb. I do the same thing for Q34 because Q34 over Q total equals C34 over C equivalent implies Q34 equal Q total, which is yeah. So it's C34, which is a 3.33 e to the minus 6 times Q total, which is a 3 e to the minus 4 divided by C equivalent, which is 3.33. And I get, just a second, C34 is 1.50. So I get Q34 1.2 e to the minus 4 coulomb. Okay, so if I have Q12, implies I have Q1 and Q2 because they are equal. So this is equal to Q1 equal to Q2, and this is equal to Q3 equal to Q4. So I got the charge across all the capacitors. Finally, do it here in a different color, differentiate. So for C, calculate the potential difference across each capacitor. So again, V1 will be Q1 over C1, V2 will be Q2 over C2, V3 will be over C3, and V4 equals Q4 over C4. Okay, you just plug the values. So I have Q1 and Q2. Here they are. Okay, and Q3 and Q4. You just plug all the values and you get all the voltage across across the capacitors. So V1 you will get it to be equal to 60 volts. V2 is 30 volts. V3 is 60 volts. and V4 is 13 volts. That this makes sense because V, which is 90, should be V1 plus V2, and V should be V3 plus V4, and V should be the V across C12 and C34. So 90 should be equal to 90 across the battery. So these numbers make sense. Okay, so that's it for today's lecture. Tomorrow I will solve one more exercise on this and review the whole chapter.